Alright, so today we're talking about difference of squares. And the first thing you need to realize or recall is your perfect squares. You need to know them, you need to be able to recognize them. Because when you see them when you're factoring, you need to check to see if it's a difference of squares. I got 1 from 1 squared. I got 4 from 2 squared. 2 times 2. You see that pattern? Alright, so let's take square roots. What's the square root of 169? It's a perfect square. 13. What is the square root of 25? 5. What is the square root of 121? Alright, next, you're going to have variables. Any variable that has an even exponent is a perfect square. If that little number is even, if that number is an even number, it's a perfect square. So, how did I get x squared? What's the square root of x squared? Okay, if you recall from when we did square roots, x squared is really x times x, right? Whenever you have two numbers that are the same underneath the radical, you circle them, they're buddies, and then one comes out. Okay? One comes out, and that one goes away. So that is x. Square root of x to the 4th would just be x squared. Take that number, that exponent, and divide it by 2. Square root of x to the 8th power. What is 8 divided by 2? 4. Okay, yeah, you're taking this number and you're dividing it by 2, and that's where we get 4.
That one's 10.
Right, so it'd be x to the 10th. And when you take the square root, the radical goes away.
That one's 50.
Right. So if it's an even exponent, is it a perfect square? Yes. If it's an even exponent, it's a perfect square. Just take your exponent and divide it by 2. Okay? Alright, this is our first example. When you have difference of squares, first thing you want to see is there a subtraction sign? Is it a difference? Yes. Are both of these terms a perfect square? Yes. Anything with an even exponent is a perfect square. X squared is a perfect square. What's the square root of x squared? So, like we did here, divide that number by 2. Okay? So, if you take it and take the square root, 2 divided by 2 is 1. So, it's just x. So, x is going to go here and it's going to go here. You're going to set up 2 sets of parentheses when you do these. Okay? And what goes here is going to be the same. It's going to be the square root of the first term. Square root of x squared is x, and it goes in both of these places. Is 4 perfect square? Okay, what's the square root of 4? 2. So 2 goes here and it goes here. You just factored with difference of squares and you're done. Alright, look at example 2. We've got to make sure it's a difference of squares. Is it a difference? Is there a subtraction sign in the middle? Yes. Is x squared a perfect square? Yes. Is 25 a perfect square? Yes. Remember your perfect squares? They were
Will they
there.
always be x squared?
Difference of squares has to be a perfect square in order for you to factor it like this.
What if it's not like any of those numbers?
Then it's not a DOS. Good question. Alright, so when you know for sure it's a difference, both terms are perfect squares, go ahead and set up two sets of parentheses. Oh. Inside your parentheses, you're going to have one plus, one minus. You can do plus and minus, or you can do minus and plus. I don't care. You've got to have one of each. I tend to go plus, minus. So set up your parentheses. Right. What is the square root of x squared? X. That goes here. That goes here. What is the square root of 25? Goes here. Goes here. Yeah, it's really easy. Alright, let's try some.
Are you giving us any like squares with these things?
I need to check the calendar. Probably beginning of next week. Is what I'm thinking. Gotta adjust because of the schedule. Alright. I want you to try example 3 on your own. I'm gonna come around and check and see what you do. Alright, so you guys have flown through these. Good job. This one. Well, you gotta make sure it's a difference of squares. You've gotta check. Always check. Is it a difference? Are both terms perfect squares? This one is. So set up your parentheses. 1 plus, 1 minus. What's the square root of the first term? X. What's the square root of the second term? 12. There you go. You just factored that. What about example 4? Whoa, 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 whoa.
It's not a, oh, it's a plus. Oops. And it's not a...
I didn't catch that with some of your papers. How many of you put x plus 13 times x minus 13? Okay. It's not a difference of squares. Because it's a plus. You've got to have that difference sign, that subtraction sign in the middle. So this would just be prime. Moving on. Alright, so let's mix it up a little bit. Remember, first thing we learned was GCF, because we can carry that throughout factoring. You always check to see if there's a GCF. On the questions we just did, there was no GCF. There was no number that they had in common. You just went straight into DOS. Here, it's a little bit different. You can actually factor by GCF first, then you can factor by DOS. Okay, so look at example 5. Do they have a number in common? No.
Yeah.
Does 2 go into itself?
Yes.
Yes. Does 2 go into 32?
Yeah.
So factor out of 2. When you factor out of 2, you're left with x squared there. When you factor out of 2 from 32, you're left with 16. Right? When you divide by 2, divide by 2, that's what you get. That's what you get. Now, is x squared minus 16 a difference of squares? Yep. Factor it. if we factor this, don't forget about that 2. It still stays outside. Don't forget about it. Set up your parentheses. One plus, 1 minus. What's the square root of the first term? What's the square root of x squared? Just that. What's the square root of 16? 4.
So I thought we were doing 9x.
Almost. Alright guys, look at example 6. This is another one you're going to come across. Is there a GCF? No. There's not a GCF. If you list out the numbers that 9 and 25 have in common, the only one you'll see is 1. So there is no GCF. But still, don't automatically go to prime. Keep looking at it. We've got to determine, okay, does this meet all the criteria for difference of squares? Well, first off, is it a difference? Is there a subtraction sign? Yes. Now, are all of these terms perfect squares? Is 9 a perfect square? Is x squared perfect square? Is 25 perfect square? Yep. So again, set up your parentheses. Once you know it's a difference of squares, go ahead, set those up. 1 plus, 1 minus. Now, we've got to take the square root of both of those terms. So the square root of 9x squared is what? What's the square root? 3x. Square root of 9 is 3. Square root of x squared is x. So 3x. And goes here too. What's the square root of 25? 5. 5. Okay. Let's do one more and then we'll do homework. Remember what I said about even exponents. If it's got an even exponent, it's a perfect square. You just got to divide it by 2. Okay. Is this a difference of squares? Yep. Because it's a difference, there's a subtraction sign. X to the 6th is a perfect square. 49 is a perfect square. Set up your parentheses. What's the square root of x to the 6th? Well, if we need to go to the side, 6 divided by 2 is x to the 3rd, or x cubed. That goes here. That goes here. Oh, I forgot. Plus, minus. Now, what do? 7. Yep. Square root of 49 is 7. Goes here. Goes here.